Hi everyone, good morning. I am Sonia from the Unacademy and Coach Chef team, and we're just checking if we are live on YouTube or not. Give me a moment, guys. I think we are. Wonderful. Good morning, everyone. I'm just going to start sharing my screen and we can start with the presentation and the discussion that we've planned for today, which is around stacks. Okay. Um, Good morning, everyone. Hi. My name is Sonia Motwani. I'm a part of Unacademy and Coach Chef team, and today's session is on stacks. This is a quick morning session that we are having as a part of our DSA learning series, where we teach you something in theory and then teach you something else in practical, so that in the form of code, so that you're able to register and remember these things for life. And today's class is on stacks. Um, let's just check if we are good to go. This is going to be an interactive session, guys. So if you have any questions, please feel free to type it in the chat comments in the chat box. I will be able to see them and answer them for you. Okay? All right. I think we can get started. Just to introduce myself again, I'm a graduate from BITS Pilani with 7 years of work experience. I'm a competitive programming educator with Unacademy and Coach Chef, and I have worked with finance companies in the past. My interest has been in working with banks, fintechs, and NBFCs. All right. Um, for those of you who do not know, Unacademy, while has a free account that you can create and learn from there, they also have a plus subscription where you can get access to unlimited classes, courses, and batches. There's a structured learning path which is created for learners, but I think I'll cover this in the second half of the session and we can get started on learning about stacks first. All right. Um, the thing that I like to usually start with is kind of highlight the importance of data structures and algorithms, right? And because tax is also a part of data structures, right? So understanding why data structures are really important becomes necessary for us. If you see the image over here, it talks about what happened in every minute of 2020, right? This is the amount of information that was being processed by the companies. There were 2 lakh hosts on Zoom every minute. 3.5 lakh people posted stories on Instagram. Right, Facebook had 1,50,000 messages that were going every minute. TikTok had 2,700 installs every minute. Right, these are huge numbers. These are huge numbers for us, to live by, to understand, right? And imagine all of these companies, because has so much of information coming in about the users, has to process all this information as well, right? So processing of information is really really important for these companies, because they're able to then adapt, give us more features, give us more things around these, right? So data structures, the whole study of data becomes really important. So data structures, algorithms, and a lot of other fields like data sciences, analytics have become very very important in the recent times, just because of the fact that so much information is being processed every minute of every day, right? And this is really very huge. So data structures is a way of collecting and organizing data in a way that we can perform operations on these data in a very effective manner, right? And um, that's where we have multiple types of data structures that we talk about as well. Yeah. So data structures is about rendering all the data elements in some sort of a relationship for better organization and better storage. Data storage is something that we've been observing in our lives forever, for a very long time, right? In school, where your teacher would write down your marks, your against your number, and then there was a table where you could see all your marks, your report cards. These were all data structures that were there around you, right? These were all tables. These were homogeneous across all the students that were attending this particular school, right? So the example that I've given over here is like, Virat in 26, Virat is a character data type, and a string data type, and 26 is an integer data type. So whenever we have to store similar things in the data, they're going to be placed in a similar format, right? They're going to be placed in a similar format. So data structures, basically, because the structure has been created around it, we are now adding more elements to it in a similar way. A report card, taking for example, a report card, everybody used to get report cards in school, and everybody's report cards had the same fields. There were 5 subjects, 6 subjects on the left hand side, and then there were marks, and then there were grades assigned to it, right? This is the form of a data structure that has been replicated across the school, right? All the elements are in some relationship, they are stored together, right? And they're uniformly spread across all the learners that are there in a particular school. So that's the first type of data structure we would have seen, we would have realized, and we would have come to a structure around it this way. Yeah, that's what we mean by data structure. And companies need to collect this at a very large scale, because they need to perform a lot of operations on all of these, right? So for example, if your school wanted to then understand sorry, if your school wanted to understand when you were a kid, as to how many students are how many students are getting between 50 and 70 in say any of the languages, say English or Hindi, right? And possibly give you remedial classes around it. They could have done that if all of it was stored in a digitized format somewhere, right? And a lot of companies are now saying that predictions about a child's future can be made around the kind of marks that they would score in school, right? So people who were generally decently good at mathematics were the ones who would go ahead into technical fields, into programming kind of things, right? So for all of you who were back in school, who were good at math, I'm sure this is something that you've been able to relate to it as well. But these are all very directional studies, these are all very directional information that was gathered at that point. Again, because there was no data structure created around it at that time, that's not a conclusive result. So data structures help us in doing so many more things, right? Structured programs are created by companies in order to store data so that various operations can be performed on it. Yeah. Various operations, and there's a whole new field of data which is basically used to perform various operations, right? So data sciences, data analytics has become like a whole new field in itself, because data is being stored correctly and effectively. There are lots of operations that can be performed on it. Yeah. It Data structures represents the knowledge of data to be organized and implemented in such a way that it reduces the complexity, increases the efficiency, right? The whole reason why we're doing this is because are doing this is because it should be efficient for us to do this, right? It should not be time consuming, it should make things simpler, it should make our life simpler, right? So a computer program, basically, whenever we write a program, is for a computer to perform certain tasks and activities, right? So to do any task or activity, computer needs to store data, retrieve data, and perform functions on the data, which is why data structures become essential. Yeah, anything that can store data can be called a data structure. So your basic float, boolean, character, these are all data structures as well. These are built-in data structures that are there inside every computer, in the memory of every computer, right? So these are built-in data structures that we already know of. There are some other complex data structures which use and store large and connected data. Some examples, if you can see on the right hand side, we have some built-in data structures, and then we have some user defined data structures also, which are your arrays, lists, and files, right? So your arrays, lists, files, inside this we have your linear and non-linear data structures as well. So stacks, queues, trees, graphs, I'm sure these are some concepts that you're already familiar with, and stacks are what we're going to be focusing on today. And along with stacks, I've also added a little bit of information around queues, and what is it that you can learn about queues, how is it that stacks are different from queues, because these are the kind of things that get asked in interviews also, right? So we have some built-in data structures: integer, float, character, pointers. Yeah, we have some user defined data structures, which is your arrays, linked lists, files, graphs, trees, stacks, queues, etc. Okay, so Let's start with understanding a little about the different kinds of data structures that we have. So our linear and non-linear is something that we've already spoken of, but there is other types of categorization done on data as well, which is homogeneous, non-homogeneous, static, and dynamic, right? So your linear and non-linear data structures are where all the data items are arranged either in a linear format or in a non-linear format, right? So if you can imagine graph right now, if you can visualize graph right now, you'll realize that there are multiple layers in it. That's a non-linear data structure. Whereas if you can think of an array, a stack, or a queue, yes, all of these are linear data structures that we have. Yeah. Homogeneous and non-homogeneous is another categorization. In homogeneous, basically data elements are of the same type. Yes, all the data elements are of the same type, and a good example of that is array. In a non-homogeneous data structure, elements are not of the same type. Elements may not have been of the same type because the data is not homogeneous in nature, right? Hey Ayush, hi Ramu, how are you guys doing? Good morning. Good to have you in the session. Guys, we're learning about stacks. Yes, this session is to discuss stacks as a data structure, and I started with talking about how humongous the complete data is in the world, and sorry, the different kinds of data structures that we have and the characteristics of data. That's your linear, non-linear, homogeneous, non-homogeneous, static, and dynamic. Yeah, good to have you guys in the session. Okay, so homogeneous and non-homogeneous are the data structures that we just spoke about. There is homogeneity in the kind of information that is presented, and then there's non-homogeneity as in the different kinds of data elements that are present. Yeah. Static and dynamic. Static are basically those whose sizes and the structures associated with it are fixed and they compile at a time. Dynamic are where the size can expand or shrink depending upon the program need and its execution, right? So arrays are your static data types and dynamic data types are your linked list using pointers. Yes. Ramu, you wanted to understand if you'll implement stack today? No, stack discussion is today. Stack implementation is in the next session, Ramu. Yeah. But you can attend. We're going to do this for just it's a quick 15-20 minute session only. We're going to be covering the basic concepts, and in the next class we are going to be talking about an example, and we will be implementing stacks. Yes. Thank you. Hi Satyendra, how are you? Good morning. Satyendra, I think I'm seeing you in my classes for the first time. Good to have you. Good to have you in the class. If there are any questions, guys, please feel free to type it in the chats. I will answer them for you. Yeah. We just learned that data is the amount of data that is being collected by companies is really very huge. There are multiple types of data types that we have, and there are different characteristics of the data that we've identified. Okay. Traversing through billions of data points. I'm sorry, this is not missions, this is millions. Spelling mistake. Traversing through millions of data points can be a really big challenge, which is why we create algorithms. Algorithms are just a set of instructions written in order to accomplish a certain predefined task. Right? Algorithm is not necessarily the complete program. Yeah, it is just the core logic or the core solutioning of the program, which can be expressed as a high level description or a flow chart, right? So I'm sure you would have realized this, that whenever there is something complicated that you want to write, flowcharts are one of the ways that you go about writing it. Yeah. So algorithm also in a way is not the complete code of the program, is just the core logic or the core solution, which can be expressed either as a high level description pseudocode or as a flowchart. Data structures and algorithms actually go hand in hand. Data structures and algorithms is not the same thing. Because we have DSA as a course, everybody thinks that data structures and algorithms is the same thing, but it is really not. They go hand in hand. If we understand data structures well, then we'll be able to understand algorithms also really very well. Yeah, but just that a lot of learners keep getting confused about these things. Okay. Let's learn about stacks. That's what the course here is about. This is what the session is about. So stacks are basically used for maintaining function calls, right? And the functions are created in a way, and I'm sorry, I think I've missed out on adding the definition of stacks and just written the application of stacks. but no worries. Stacks are basically a linear type of data structures, yes, and they follow a last in first out strategy. They have two basic operations that they perform, which is push and pop, right? Both pushing and popping happen from the same end of stacks, so if you can imagine this being a stack of data, this is a stack of books here right now, and anytime you want to add a new book or you want to remove a new book, remove something from this, anytime that you want to remove something from this, both of these operations are happening from the top. Pushing is adding of a data element, popping is a removal of a data element. Pushing and popping in stacks happens only from the same end, yes. They are basically used for maintaining function calls, so whatever you have called in the last is the first thing that gets executed, right? So when there's a lot of task list or activities given in some sort of a priority order, you can think of it that way, yeah. Or there are some real life examples that I've in fact cited are like plates on a tray, a stack of coins, a stack of drawers, right? These are typical examples of stacks. Whenever you want to remove something from this particular stack, you remove from the top. Whenever you want to add things to it, you add it to the top as well, right? So stacks are implemented also in the same way. Last in first out strategy, pushing and popping are the two functions that they do, and both of these happen from the same end, which is the top, right? The stack starts from the bottom, it goes to the top. Pushing and popping happens at the top, yeah. So and this is something that you would have realized as well, when you go to a wedding, when you go to in the mess of your college, etc., there are lots of plates that are arranged for you, right? Lots of plates that are arranged for you. You have to pick up something and then go serve yourself some food. The structure of data or the structure of plates that is there is also in the form of a stack, yeah. And whenever you pick right from the top, right? And whenever more plates are added to it, they are added to the top, yeah. Stacks are used in cases where we have to reverse a word, check for a balanced parenthesis, and when you do undo and redo, the operation that is basically performed is because of stacks, right? And removal happens with the help of recursion, yeah. Removal happens with the help of recursion over here, and the last item that you have added in is the first item that gets removed as well, yeah. This is what basically stacks are. I've missed out on adding that image of pushing and popping that is happening from the same end, but just imagine this particular stack of books over here itself, because that's the most appropriate example. And pushing and popping are both happening from the top, right? So elements are getting added from the top and elements are getting removed from the top as well, right? Addition and deletion happens from the same end. Last in first out is the strategy that stacks adopt, yeah. Okay. Just to understand if there are any couple of questions coming in here. Okay, my stream just went off. I hope all of you are able to see me. My stream on my phone just went off. Okay, yeah, I can see the stream. Ramu, you want to understand if we can read elements in a stack randomly? Yes. Interesting question. Random access is not allowed for objects that are contained in a stack. Random access is only allowed for things like arrays or linked list. In stacks, this is not something which is permissible. Does that answer your question? Yeah. Okay, I'm guessing that does. One of the things that stacks are usually compared to, yeah, thanks Ramu. One of the things that stacks are usually compared to are queues. Queues is another data structure. It's a linear data structure. Oh, I missed for mentioning list, arrays, stacks, and queues. These are four different types of linear data structures that we have. Yeah, stacks is a linear data structure. Similarly, queues is also a data structure which is linear in nature. Little different from stack. Just kind of want to introduce it to you over here. In the next session, we are going to learn the implementation of stacks. So yeah, I think that's what we'll cover. But queues is also something that we can cover in the next session. So let me just briefly introduce you. So queue is also a linear data structure. Yes, it follows of the first in first out strategy. It's an abstract data type. It contains elements with two principal operations. There's NQ and DQ. NQ is when elements are added from one side of it, and DQ is that elements are removed from another side of it. So if you can see in the image also on this particular side, right, on the right hand side, you can see the image very keenly. You realize that there is NQ and DQ, which is happening in a queue. NQ is happening from the back of the queue, and DQ is happening from the front of the queue. Like in stacks, we had push and pop. These were the two operations that stacks perform. Push and pop, both were happening at the same end. In queues, there is NQ and DQ. Both of these happen at different ends. NQ happens from the back, DQ happens from the front. Yeah, and this basically adopts a first in first out strategy. So whichever thing came in first moves to the front and DQs. Whichever thing came in last, whichever data element came in last, moves to the end, and is NQ'd towards the end as well, right? So element is removed from the front, is added at the back. And implementation of queues can be done both in array and linked list. A very typical example is queues that you have at the ticket counter of a movie, or at the bus counter whenever you want to buy something, right? Or at a store at Big Bazaar, where you kind of want to get billing done of all your of all the things that you've purchased, right? So queues are applied over there. And how it happens also is whoever enters the line first is the first one who gets out also, and more people keep getting added at the back. So queues, like the name suggests, is typically queues, right? Is the queues that is the line that you form, is the queue that you form at multiple places. And this follows a first in first out strategy. So back of the queues when people get added, front of the queues where people get removed from. Yeah. And in computers, it is performed on things like CPU scheduling, a disk scheduling, right? When data transfer needs to happen asynchronously, this is where the application of queues is, right? These are what we have in queues. In stacks, we've understood that the application is whenever we want to perform the last function immediately, and we want to undo something that has been done, right? This is how the stacks are applied. Queues are applied in reality in the form of queues itself. Yeah, these are all the things that I kind of wanted to teach you about. Very briefly talk about stacks. I want to know if you folks have any questions. There are a couple of learners that we have in the session right now, and my streaming seems to be going live. So yeah, feel free to ask me if you have any questions. I can otherwise talk about, for 1 minute, just talk about the Unacademy Plus subscription that we have, and how is it that it can benefit you. Yeah. So, like I was telling some of the other learners who joined at the start of the session, Unacademy, you can create a free account with Unacademy, and access all our courses and classes for free on the platform. But there is also a plus subscription that we offer here, which is called the Unacademy Plus. Inside it, you have a lot of structured learning paths which have been created. The Unacademy free subscription does not necessarily have a structured learning path. There are a lot of courses that are available to you for free. Of course, you can watch all these videos with just a free account that you have created on Unacademy platform. Yeah. And in Unacademy Plus, you get structured learning paths that are created for you. There's one subscription that allows unlimited access to all possible batches and courses, and our courses have been created and aligned in a way so that you are able to crack the interviews of all your top product companies. The people that are teaching you are the best coders that India has right now. And our learners have been able to successfully contest in competitions like ICPC Code Jam. All of these things come under under plans that are for less than 90 rupees per day. I've added the costing towards the end of the slide. Yeah, these are the rates that are actually offered to you by Unacademy, but there's an additional 10% discount that you can get if you use my referral code, which is Sonia Motwani. I'm going to leave it on the slide and check if you folks have any questions. Ramu, Satyendra, Ayush, anybody else who's been listening in on the class, any concerns, any information about stacks that you might need, happy to help out with that. Guys, this session was around stacks, was around the theory of stacks. We'll have a couple of classes around practical applications of stacks as well. Give me a minute. Yes, these are what we discussed today. And we keep having classes every Tuesday, Thursday, and Saturday mornings. There are a few concepts that we teach. Sometimes the classes are more informal, around lines of telling you and introducing you to the whole world of comparative programming and what kind of jobs and roles you will end up doing once you join in. But yeah, this is all that I planned for today. I can wait a couple of seconds and see if you folks have any questions. Otherwise, we can call it a day. Thank you so much for attending this morning session with me. I'm Sonia Motwani. See you soon. Bye.